So greetings to all. So welcome to this video session. In this session we are going to see the simulation and verification of digital circuits. So myself Raj Prabhu and Ashok sir is going to present this video and going to show the demo on how to simulate the basic circuits, that is combinational as well as the sequential circuit, using a microwind tool. Microwind tool is a basic simulator tool which is used to verify the functionality of a circuit. Basically the microwind, which is mainly used for front end design as well as the back end design. We can verify the functionality of the circuit using the gates as well as the transistors in the front end. At the back end we can generate the layout and we can verify the functionality. So now we see the simulation of basic gates using the microwind tool. So this is a screen, basic screen of a microwind tool. So we are having several options. In the right side we are having a symbol libraries, list of symbol libraries, and also in this library we can have a n number of tools, which is a button used for giving a input as well as a ground, and then giving power supply, and then clock signal, and next one is a LED and display, hexa display, and then a basic gates. And then if you are going to simulate using a transistor level, we are having certain transistors, inbuilt transistors, library transistors, and we can use it here. Now I will show the simple demo using a gate, simple gate. For a NOT gate, we need to press this NOT gate and then drag it to the center. So this is a NOT gate which is having a single input and single output. In order to give a input, we need to select a switch as a button, and then we have to select the output. So for the output we need to connect this LED. So in order to connect this button to the gate, we need to connect it by wire. So wire, we are having certain options here. So the first one, which is having say open file. If you are having any examples, if you want to open any examples, you can use these options here, and then you have to save this one. And then if I want to convert this schematic into a symbol, new symbol, if you want to create any logic and then you have to use it in the another circuit, you can create a symbol here. So and then this is a normal arrow button, and then this gun, this is nothing but used to delete a particular portion of the circuit. And then copy, if you want to copy any element in the circuit, you can using this copy, and then drag. These things are used for drag options. And then you can edit, you can add a text in the circuit, and then add a line, that is you can connect it wire. Using this symbol you can connect a wire. So now I selected this option. So and then press the input side, that is a button, and then connect it to the input of a NOT gate, and then the output of the NOT gate to the anode of the LED. So this is a very simple NOT gate circuit. So now if I want to simulate this one, now if I press this button, it does not show anything. Now in order to simulate this one, I have to press this run simulation button. There is a play button. If I am press this play button, then it will show a output. If this is not enabled, which is in black, 0, it represents 0. 0 means the output of a NOT gate is 1, the LED gets blinked. If I am giving the input as a 1, then output shows as a 0. So this is 1 and 0. So now after giving a number of inputs, we can stop the simulation, and I can view the timing diagram here based upon the given inputs. Timing, based upon the timing we can view the output here. So at this time I have pressed the input button, so the output is high, output is a low. So this is a timing representation, another timing diagram of a given circuit. So next I am going to simulate a basic half adder circuit. For this first I have to create a new workspace. So I am not going to save this one, since it is a basic thing. I am not going to save this one. So for a half adder we need a XOR gate in order to produce the sum. I am dragging this one, and then one AND gate, 2 input AND gate. So here we are having 2 inputs A and B. I am going to take this as A and B. For that I am taking a button, 2 buttons, input 1 and input 2. I can change the text also here. For a reference I am giving this as a and B, input 1 as a input 2 as a B. So and then I am going to connect this one for a half adder circuit, XOR gate A XOR B. If a 2 wires get connected, you will show this as a dot button here. You will show a dot here, then only it shows it get connected. So next, in order to take the two outputs, I am taking LED, 2 LEDs, one for sum and another one is for carry, and the out one LED represents the sum. Out 2 represents the carry. So now we can verify the functionality of this half adder circuit. So now if I am giving the 0 0 input, then it shows the sum as a 1 and carry as a 0, and then if I am giving 0 and 1, sum is 1 and carry is 0, and if I am giving 1 1 value, the sum is 0 and carry is 1. And also we can view this using a timing diagram also, so we can verify the functionality in this timing diagram sheet. So likewise we can verify the functionality for different circuit. So now if I am going to use this half adder for some other circuits, we can create this into a new symbol. So this is my symbol for a half adder. So here this symbol represents, the box represents the half adder having 2 inputs, in 2 and in 1, and out 2 and out 1. We can alter the positions also for out 1 as a first, as a second one, This is the first one. We can also change this. So likewise we can create n number of symbols in order to use this particular circuit in some other projects. So if I want to take this created symbol, you can go for insert user symbol, we can pick it from here, half adder circuit 1. If I am clicking half adder circuit 1, we can having a circuit. So inside this one we are having a XOR gate and AND gate. We are having two inputs X, Y and some AND carry. So now sequential circuit will be explained by Ashok sir.
Okay, thank you Mr. Raj Prabhu. Already Raj Prabhu sir explained how to use microwind, what are the tools, what are the components available in microwind, and how to verify basic gates, NOT gate, AND gate, OR gate, and he demonstrated how to verify half adder also. Now we are going to look at the demonstration of sequential circuit. Okay, sequential circuit means first we are going to demonstrate D flip flop, how to check D flip flop. Okay, so first to open new, yes. So here D flip flop is available, tracking this one, and already you know the pin diagram of D flip flop. There is a D pin and RST, restart pin, clock pin. Next output Q bar, both are available. Here Q bar is indicated by NQ. So for input we are choosing the button. For restart we are choosing the button. For clock we can choose button or clock. It will provide the continuous clock. Button means provide a single clock. So for here we are using the single clock. For output verification we are using the LED. Right. Now I am going to connect the circuit. For input D is connected to button 1, RST is connected to button 2, next clock is connected to button 3. So Q output is connected to LED. Right. Now I am going to simulate the flip flop. So by using flip flop we can design the registers and counters. Registers means serial in, serial out, serial in, parallel out, parallel in, parallel out, parallel in, serial out registers. By using these flip flop we can design the registers, and we can use JK flip flop, T flip flop for designing the counters, asynchronous counter, synchronous counter, like that. So now I am going to verify the truth table of D flip flop. So D flip flop provide output only input is 1 and clock. So there is a 2 clock, one is positive edge clock, another one is negative edge clock. Here output is provided only at negative edge clock. So I am going to give input 1, right. So please now check the output, there is no output. Okay. Now I am going to give clock. So clock negative edge means there will be output 1, right. So now I have to shift 0. 0 means I am giving input 0, I have to get 0 here. If I click this switch positive edge, there is no change in the output, right. I am giving negative edge, so input will appear on the output, so 0 appear on the output, right. Now input is 1, next RST also 1. I am going to give clock, I am changing clock 1 to 0, but there is no change in the output. So, due to RST. So, RST means it will reset the output. So, I am I give 0 to the reset button. Now, I am giving 1 to the clock. So, negative edge means it will provide output. So, by using this D flip flop, we can design any number of registers, 1 bit register or 2 bit register or 3 bit registers. Okay. I hope you all are understand about microwind tool, combinational circuit, sequential circuit, how to verify the combinational circuit and sequential circuit. Okay. Thank you very much.